let's understand these equilibrium constants just a little bit more. Okay, if we have a large K, all right, we are going to favor the products. So if you look here, I've got a picture. I've got some hydrogen molecules, I've got some bromine molecules, and I have some hydrogen bromide. Okay, this particular reaction has a large K. So my little picture over here, this is a reaction at equilibrium. Okay, so that reaction at equilibrium, let's take a look here. I have a hydrogen, I have a bromine, but then I have a hydrogen bromide, a hydrogen bromide, a hydrogen bromide. Oh, look, it's almost all hydrogen bromide. So large K favors products. Okay, so when we have a large K, we're going to form more products. All right, now when I look at a small K, so here I have some nitrogen molecules and some oxygen molecules and some nitrogen monoxide. So again, this little picture right here, this is the reaction at equilibrium. Okay, so when you look at the reaction at equilibrium, what do you have more of? The reactant molecules or the product molecules? You'll see that there's more of the reactant molecules. So a small K favors reactants. Okay. All right, so again, small K, now I just have single color things. Small K favors our reactants, large K favors our products, and an intermediate K is going to be somewhere in between, and so you're going to get a good mix of both. All right? So when we look at the order of magnitude, all right, when we look at the order of magnitude, if we have a K that is 10 to the third or greater, products will heavily predominate. If our K is 10 to the negative third or smaller, the reactants will predominate. So when we looked at KSP values and we look at Ka values, these guys are really small. Most of them are smaller than 10 to the negative third, or they are 10 to the negative third, which means that they don't disassociate very much. The equilibrium favors the reactant, so we don't get a whole lot of those ions being formed, all right? And so when we do some of these equilibrium calculations, we get a lot in that intermediate range between 10 to the negative third and 10 to the positive third. If we have a very large K or a very small K, we can actually do some things that give us some really important assumptions. Now, in this class, for this level, we're not going to deal with anything really complicated or needing to worry about any of these assumptions. All right, doing this gives rise into a lot more complicated chemistry that we don't go into in this particular class. But it is important to understand, you know, this part up here. All right, that if you have a really small K, you're not going to get a whole lot of product. But if you have a really large K, you're going to get mostly product. Okay? And so for people that like a visual better, here you can see on a number line, all right, if you've got a good intermediate K between that 10 to the negative third to 10 to the positive third, you're going to have significant amounts of both reactants and products present. But if you're really low beneath that 10 to the negative third, you're not going to get much of the reaction at all. And then the higher you go, the greater than 10 to the third you get, the reaction will start to proceed close to or near completion. Reactions that go to completion, like say the dissociation with strong acid, we don't even have K values for those because they dissociate completely. It goes to completion, so there's no Ka value necessary. We only have them for like those weak acids. All right, so that's how we understand our equilibrium constants.